Good morning. Today is Tuesday, March 5th, 7:34 a.m. on the Pacific coast of North America. A couple of items today, actually three main ones. One is the sinkholes. These are appearing all over, and these are, as forecast sometime back in one of our reports, I don't know, maybe even in the old Alta reports, there was some discussion of them a number of years ago. Sinkholes are a sign of, or not a sign, they're a side effect, necessary component, but from our viewpoint, a side effect of the expansion of the planet. As the, you can think of it basically as lots and lots and lots of little rocks glued together, Earth, and then in the middle of it there's a plasma ball that's all electrically hot, like the very hottest part of the arc in an arc welder, and it receives energy from the sun, and it grows, and when it grows it pushes up against the solid cooler matter that surrounds it, and eventually it creates more of this solid cooler matter, which causes the whole of the planet to get bigger, a little heavier, which is ultimately what does in all of the critters that are too tall when we were low gravity. But anyway, it pushes the planet apart from the inside. And so one of the necessary components of this, and as I say, was one of the forecast components of the expansion event, was the appearance of sinkholes all around the planet. Because basically what's occurring is that the various different layers of rock are separating all over as the expansion is pushing them out. And as that occurs, those areas that can separate easily will do so, path of least resistance. On top of them may be other areas that are not going to separate so easily. And it will take a while, and then they'll rupture a little bit as well. And we get these sort of, I want to say, funnel-shaped effects, because as the more dense material in the middle of the planet cracks and separates a bit from the pressure, it allows areas on top of it to shift a bit, and opens up a little bit wider and a little bit wider. And you can see that because of the, if you think of Earth not as a sphere, but as a sort of a sphere with a beer belly around the middle. So it's got this little bulge, this little tire around it. And that tire is large enough to be appreciably seen. If you were out in space and you were far enough away, you could see that the Earth is in fact sort of flat around the middle. As it expands, and because of its rotation, just like if you were standing in the middle of your yard and you had a 2 or 3 foot long rope and a weight on the end of it, and you started spinning around with yourself acting as the center of that spin, you would feel that weight pull on your arm as it wants to leave you from the centrifugal force. We're getting sort of that same effect here from the inside of the planet. But what happens is, because of the various layers of material, they're not all going to open up all at once. So, for instance, the sinkholes we see on the surface are not direct holes all the way down to the middle of the planet or anything. It doesn't work that way. Rather, what's actually going on is that smaller and smaller gradients of pressure smaller and smaller instances of expansion are experienced as you go further into the middle of the planet, but that each layer that it expands causes a necessarily larger level of expansion on the layer that's around it. So it's kind of like with an onion, and you can see that with the many layers, so the skin on the outside of the onion must separate and break if the layer immediately underneath it were to enlarge itself. And that would be true all the way down in the onion. If one of the layers down in the middle of the onion enlarges itself, and we allow for this, that the onion could expand, then each layer above it would have to expand. And in order to do that, if these layers are fixed, if you will, if they can't grow, unlike the layers in the middle of the planet, which actually are growing, as you get out to layers we're on, they can't grow. We can't suddenly add new dirt. It doesn't work that way, and it wouldn't fill in the gaps. All of this material has to come up from the middle of the planet. So each outer layer has to necessarily separate at a larger level than the layer below it, and that's what forms these conical or even rift-like separations. And these are a natural effect. We've seen them occur. We can, if someone were to have been really smart, they would have plotted, as we did, the occurrence. We did it on language as opposed to the actual sinkholes themselves, and so that's a little misleading. But what I was going to say, if someone was really smart, they could have plotted the occurrence of sinkholes and just plotted those right along with earthquakes, and you'd be able to just catch the expansion as it's occurring. You can see it happening. So anyway, we've been aware of this here at Half Past Human for a number of years, that the sinkholes were going to appear and get worse and worse and worse as part of the expansion process. This is a natural part of how Earth works. Now, the key thing for humans is don't be on a sinkhole when it forms. You know, that's the the central part here, is that the sinkholes, as they work their way up, will cause ruptures. If you're in areas like Florida, for instance, or the sandy coastal areas that we have so infrequently here on the West Coast, except as you get further down towards the equator. So, for instance, our beaches up here in Pacific Northwest are in the main made out of either mud or gravel. we don't have sand. You get some sand down in Oregon in that area, but anyway, so what happens is the various layers open up. Small hole at the middle of the earth or a small hole in a layer as the earth expands, and that layer cracks, and it causes the crack to spread all the way on up. And you can see that because the cracks wouldn't instantly form from the inception point all the way to the surface of the planet, and have to work their way up from layer to layer to layer with various different layers of resistance. This is what actually forms the sinkhole effect, where you're just sitting there, all of a sudden right next to you, clump, the ground sinks in, and you're scrambling and running like hell as a big funnel opens up around you, and you're in the process of trying to not be in that funnel. Well, the sinkhole effects are going to be all over the planet, but get this, we'll find that they are concentrating in the northern hemisphere. We'll also find as we go along that they're going to be concentrated initially. They were more equatorial than not, and then they started creeping. And we've seen the creep head way up into the latitudes. I'm expecting it, I think we're about 38 or 39 in latitude in terms of the more persistent bands of the sinkholes at this point. I'll ask Igor next time I'm chatting with him about these. But I suspect it'll go all the way to the North Pole. We'll have some level of sinkholes in the southern hemisphere, but because of the nature of the southern hemisphere not being jam-packed with continents putting pressure on it, and it has a whole lot more latitude in terms of more leeway in terms of being able to form and separate and allow the rocks to move and so on. So actually in the southern hemisphere, we'll get the opposite effect, in my opinion. Instead of getting sinkholes, we're going to get new islands. And this has to do with the nature of the amount of mass relative to the ocean floor. In the northern hemisphere, where we have the huge mass of the continents, it's not possible for it to put new matter up directly. And so we get the rupture here. In the southern hemisphere, because of the huge cracks that were in the Pacific Ocean and the absence of material that used to be Krakatoa in the giant supervolcano Toba, because of that material being gone, it's like there's a little bit of room to slop around, and we don't get the sinkhole effect. We get its opposite, which is that as there's less pressure on top of the southern hemisphere in terms of the amount of weight, actual mass from the continents. And so when the onion in deep in the earth ruptures its layer, and it's in the southern hemisphere and it works its way out, there's less pressure around the edges of where the crack's going to form, and so frequently in the southern hemisphere, material will start moving into the crack as it is working its way up through the surface, and that material will include the more volatile and fluid materials, and so when the crack actually shows up mostly in the ocean in the southern hemisphere, instead of causing a sinkhole, which it probably does to some extent initially, but then is almost immediately filled with material trying to get out, and that is what forms our new islands. So that's actually the process that's going on, and in my opinion, and I'm an unschooled, self-educated bastard, so what do I know? But I was talking about sinkholes in 2003, 4, and 5, way ahead of the appearance of them all. Now, the sinkholes here that we're getting are of some concern, because there's a big sinkhole, in my opinion, that's formed over on this particular eastern ridge limb of the Chatham Trench near New Zealand and the Solomon Islands. And that is where I suspect that the crack in the Pacific plate will occur. If you get enough of these sinkholes in the southern hemisphere and they create new pinpoints of matter attempting to come on through, because of there's the ability for the matter to come on through, there's not a continent sitting on it. The bottom of the ocean ruptures a bit, you get a little bit of a crack, maybe a few yards wide, maybe a few hundred feet, something like that. And a material comes on up and you start forming a small island. It doesn't have to come up very fast. All it has to do is just be there. And then it happens a little further along, a little further along, a little further along. It's sort of like the sinkholes being plugged. And it basically is going to go along in the path of least resistance and the point at which the bottom of the ocean is thinnest and is most fragile, and it'll go and form a crack. It'll come along just the way that one might crack stone by drilling in a series of holes in the line you wanted the stone to crack along. And that's what's going to occur here. Now in the southern hemisphere, instead of just being a hole, these holes will be filled by material that will be pressurized from below, creating a continual pressured wedge that, in my opinion, is going to cause the Pacific plate to crack. And I think that's what is actually the source, the source from our viewpoint of the global coastal event, which again is probably most likely, let's say, between the equinox of March 21 and May 20th, in my opinion. I think that's when it'll happen, at some time between that point. Now, it's not the end of the world. There's going to be all kinds of problems and destruction and so on, because people are stupid, basically, and we're not paying attention to what's going on around us, and there will be much destruction, and we haven't prepared for this, at least not the regular schlubs, the people, the nebbish. Instead, the power elites have prepared. They've been stashing stuff like, man, they're getting themselves all set for this. So there's that dichotomy there. We don't prepare because we've been in the Western world here, in the Anglo-American Empire, mostly schooled to a state of stupor. And if you're not schooled to a state of stupor, they give you drugs to get you there or work you to death with mindless repetition that destroys any hope you have for being able to think deeply. And then when you're not working, they put you in front of flashy lights that destroy your ability to think deeply, or they shove high-intensity, flashy strobing noise into your ears through earbuds. So boy, you're really screwed. You really can't think. And so you're not going to notice that the sinkholes are basically the real last sign that the planet's about ready to crack. And when it cracks, it's going to cause all kinds of problems. Now, this is my opinion. And I'm a doofus, and I don't really know what's going to go on. But this is a suggestion that all of my work has led me to understand. And I'm an old guy, so maybe I do know something. I managed to make it this far. I don't think I'm as old as Jesse Ventura, but I'm getting there. Anyway, so that's the thing about sinkholes. They're very important because you don't want to be on them when they form in the northern hemisphere, or the southern hemisphere for that matter. And they're probably going to be the instant proximal cause of the actual crack, is a bunch of small holes that will form. Material will come through in this line along the Chatham Ridge and cause a rupture there that will unleash a lot of magma, probably cause a whole new continent to form, or not a continent, but a big island mass, and cause some severe distortion in the southern hemisphere, as well as causing massive problems here in the northern hemisphere that we've come to identify through my characterization as the global coastal event. Now, sinkholes are going to escalate. I suspect that the sinkholes will not be hugely dominant. In other words, I don't think that we're going to get to the point where there's a sinkhole every 5 yards or anything. Might not even be a sinkhole in any given 100 square miles. But I'm sure that we'll see the level of sinkholes over the next month or so accelerate in the movement north. And so we'll see reports of sinkholes appearing in Canada and in far north in Sweden and Finland and Russia, that kind of thing. When that occurs, then you know that the expansion process is getting very close to its next stage of evolution, because once the sinkholes have gone all the way to the pole, then there won't be a second wave of sinkholes or anything. That level of opening or softening of the skin of the planet so that the expansion can occur will have occurred. And so the next phase then will be the increase in pressure at some